right. Hi, everyone. We're doing the, I know most of you actually have already done the quiz, but we are doing the official rehearsal for the in-lecture quizzes. Please take, because most of you have done it, please take 4 minutes to answer the quiz if you haven't yet. Please, I know what that is. Please go and do the quiz. Ignore the Discord. I'm gonna close it if you don't behave. Okay. Yes, so the quiz is on Quarkus. So this is the practice quiz that has already been posted. It's just that not everyone has done it. So please do the exercises. And then we'll discuss them in class. So I'm also projecting kind of the question. You can do whatever you want. You can so you can't ask a friend during the official quiz. You can try to run it and see. So the way it's going to be graded is 99% is going to be for question of each quiz. It's going to be for questions for which like everyone gets the right answer. Then 1% is going to be for getting the actual right answer. However, I'm going to tell you the answer after you finish the quiz, so you can wait around during lecture and then fill in whatever I say the right answer is. The goal is twofold. By the way, we're doing the quiz, hopefully. Hello. So the goal is twofold, right? So one is to sometimes get answers to surveys, stuff like that. Sometimes it's to give you an idea of the kind of question that it would be ideal if you knew how to answer. And 3, it's to make sure that if you're not here, at least that you know that there is an ESC180 lecture going on that you're worrying about. That's the most I can ask, right? Do the quiz. So 3 more minutes, let's say until 4:15, because there's still people coming in. So the quiz on Quarkus, go to ESC180, do the quiz. If there's any questions? Yeah. All right, the people who are just coming in, please do the quiz. There's going to be a real one at some point in the future. In fact, 12 of them. All right, who's still working on thinking about it? No one. Great. Okay. So I'm going to do this. We're going to do some exercises like this later this lecture as well. Again, kind of the global local stuff is one of the more challenging aspects of this course. So we'll just work at it. Okay, so this is question 2 from the quiz. So what's going on here? So I'll first math it out, kind of the way you would think about it as if it were a math problem, and then I will also trace it. Okay, so line 5 is the first thing that gets executed because this is just the function definition, right? It does not run until you tell it that you want to compute f of something. So the first thing that's going to happen is line 5. Is y local or global? Is it local? Anyone? Is it global? Who says it's global? Who says it's local? It is global. So I think we got the slight majority for the correct answer, so that's good. So a variable that's outside of any function is definitely global. There is no question. This is not inside a function, right? So this is not inside f. So that means that y is global. Okay, so what is going to happen here? So, right? So f is a function that computes the input plus 3. So in algebra, you would write it as f of y equals to y plus 3. Right? So that means that f of 5 is 8. And this is going to print 8. So the complication here is that there are two y's, right? So there is the y that exists while f is running, and then there is the global y. They're different variables. The way to think about it is the way you would think about what happens in math, right? So if I say like g of z is equal to z squared, so g is the function that computes the square, and then I say z is equal to 10, then I can say g of 10, oh, well, let's say g of 16, oh, that's too large. I'll say g of 100, right? And out of 100 would be, 10,000. So that does not set the value of z to anything in particular, because the z here, it could be anything, right? It could be like whatever, we're sleepy, right? That would work as well. This z is separate. So that's the example to always think about when you're thinking about, like, would z be affected? Unless you specifically say that you want it to be affected, it will not be. Does that make sense? Questions about this? Yes. So you cannot, right? Or at least kind of like you cannot with kind of normal ways of doing things, because when you say y inside here, what Python will think is you're thinking about this y. Yeah, I mean, if you change it, then sure. Yeah. Okay. So the question was like, if you change the name of y, can you then access the global y? And the answer is yes. Yeah. Well, so the question was, what would be printed where? The answer is right now, nothing is printed except the value of this. So the value of, for example, f of 5 is 8 because f computes the input plus 3, right? So unless And we'll see examples later on today where we specifically say print this or that. What's going to be printed is whatever f computes, which in this case is just the input plus 3, regardless of anything else. All right. So this prints, sorry, quiet down, please. Thank you. So this would print 8. Why? Because it says print whatever this is, and this is f of 5. Make sense? Okay. So the answer therefore was B, 8. All right. What about this one? So here, like if you run it, you'll just get an error. So the question is why? So here again, this is not an easy thing, except that there are except that there are just 2 ways to produce an error, and this is one of the ways, right? So here we're saying f of y, so y is a parameter, and we're also saying global y. A parameter is local. You cannot say that the parameter y is also global. That just doesn't work. So the other way in which you can produce an error is if you said here y equals 3 or something. Well, I mean, here that's overloaded, but if you said like y equals 3 and then you said global y, then that would also produce an error. That's the example from before. Those are the 2 ways in which the global-local conflict can produce an error that you've seen. That's it. The only other way to produce an error would be not that you've seen, that's not related to global-local, is to just kind of try to print a value that doesn't exist or something like that. Right? Okay. Questions about this? So 2 ways to produce an error, just know what they are. All right. What I want to do now is finish up a few. Oh, yeah. So yeah, so this is just you can kind of go back to last week. So or maybe the last thing you're asking is like if I say something like print, something like that, that's an error just because this is not a valid variable name. It could be. I could just copy and paste it. And now it's not an error. But if it's a variable that doesn't exist, then it would be an error. So this is kind of global local, right? So like so the ways to produce an error, so you can make the parameter be global. You could also, so I'll just do it for the benefit of everyone. You could also say something like R is equal to 5, and then you say global R. That is, again, a local global conflict, so that produces an error. This is also in the slides from last week. All right. Other questions? Okay. Okay. I hope it's not a weird GIF again. I know that we did the practice quiz, but our actual quiz is normally something assigned and due during the same lecture. Yes. So what would happen is the lecture starts. Hello. So the lecture starts. Then sometimes there is a quiz. You do the quiz. I give you the answers. You can do the quiz when I give the answers. That is fine as long as you listen to the lecture. And then the quiz closes and we move on. And then 99% of the mark is for questions that do not have a correct answer where every answer is correct. And 1% is for getting the answers correct. I will tell you the answers, but you have to be in the lecture or you have to worry about it and have your friends text you, go to the quiz. Yes. Closes at the end of the lecture? So the quiz would close around the end of the lecture, yes. Okay, so we're trying to be chill here, but not too chill. Okay. All right, other questions? All right, okay, so can you do the quiz when watching remotely? Yes, you can. So I'm broadcasting the lecture. If you wish to watch the lecture on YouTube and go do the quiz like that, Yes, you can. You can have your friends text you as long as they do it quietly. That is fine if you do the quiz during the lecture. That is all fine. Okay? So again, my point is I'm trying to get you to be worried about ESC 180 lecture in a constructive kind of way. All right? Okay. So I want to do a few odds and ends. We stopped last time when we were doing, hopefully, is that just going to be loading now? I don't know. Okay, I think it's the internet connection. We'll do the small version. We were doing this. And a person, well, on the right-hand side of the pharmacy building, got the right idea of how to do this. So let me just remind you what's going on here. So we have two Boolean variables, pie and ice cream, and they both might be false or true. And what we want is we want to output a did not lie if one of them is true and the other one is false. And otherwise, I want to say oops or something. And the goal was to write an expression here. And what the person on the right-hand side of the room last time pointed out is, actually, if you say ice cream is not equal to pie, that does the job. Because saying one of them is true and the other one is false is the same as saying they're not the same. Right? So that actually does the job. Now, I want to do it in a kind of more elaborate way, because I think once you see it, it's obvious, but maybe that's not the most natural thing that you would think of. So how would you do it in a kind of straightforward way? Well, several things you could do. So I can just say, I'm going to try to list out all the possibilities, right? So what are the possibilities here? Well, it could be that pi is true. So I'm going to do kind of a little bit of a shorthand here. And ice is true. It could be that one is false and the other is true. It could be that one is true and the other is false. And it could be that both are false, right? And now what I can do is I can just say, well, like, what are the possibilities? Well, if it's this, then I need to say, oops. And if it's this, I need to say, oops. And here I need to say, did not lie, did not lie. And I can just list those possibilities out, right? So I can say, if pi is true and ice cream is true, then I'll print oops. So, right? I encourage you to, if you're probably not used to typing kind of with arrows, it's kind of like playing a video game. It's a little bit fun, but you need to learn how to do it. I encourage you to spend the time productively and do that. Again, use the arrows, select if one is false. That is, I did not lie. And I'll just switch those. So if this is false and this is true, then again, I did not lie. Otherwise, I'll say oops. Right? So that works as well. So here I use the and, right? So if this is true and this is true, and oops. If this is true, if this is true and this is false, then I actually mistyped things. Then print I did not lie. The only other possibility is I need to say oops because it must be that both are false. Make sense? Question so far? Okay, does this make sense? Does this not make sense? Yes. Yeah, so the question is there an XOR? And the answer is like, so if you don't know what an XOR is, that's shorthand for exclusive OR. And the answer is that's your XOR right here. Right? So there is also sometimes something called the bitwise XOR, but we will not get to it until 190. There's not like that's your XOR right there, right? It's the same. So in C, this is a bit kind of just to answer your question. So in other languages, where in C there is not really a Boolean value, in which case the bitwise XOR and the logical XOR would be the same. In Python, there is a Boolean value and there's just no need. Okay, sorry. If this didn't make sense, that's fine. This was just to answer the person's question. All right. So does anyone see a way to take this and make it kind of more concise without changing the logical structure? There is actually a lot of redundancy there. Yeah.
What do you think pi is true and everything is true, or they're both false?
Yeah. We could do that, but I was thinking of something else. So we'll do your way as well. Yeah, blue shirt. Yeah.
If pi is true for loops, now if pi equals false and basically is false for loops, else I do not want to
Yeah, so the suggestion here was to basically compress it. So that's another way, but yeah, so you have another idea. Yeah, so I'll do your way as well. Yes.
You did not, and then
Yeah. So thank you. That is what I was thinking. So so the suggestion was, well, actually saying x equals true is the same as saying x for Boolean x. Right? Why is that? Well, when is this true? This is true when x is true, and it's false when it's false. When is this true? Well, this is true when x is true, and it's false when x is false because it's x. Does that make sense? So I do not really need to say pi equals true. I could just say if pi. And equally, I do not have to say ice cream equals false. I can say not ice cream. So let's do that. So I'm just copying and pasting this. So this would be if pie and not ice cream. And this is sorry, so this is if pie and ice cream rather. And this is if pie and not ice cream. And this is not pie and ice cream. And that's it. Yeah.
It would be more if not pie or ice cream, and then do something else.
I mean, I kind of did the most efficient way already, right? So anything else that I do would be like slightly less efficient. So I'll do kind of what the other people have suggested, which is kind of shorten it, right? So here I'm basically kind of typing this in twice, and I'm typing the oops in twice, which is maybe not ideal. Ideally, I would, because if I want to change it later, I don't want to change the oops twice. Maybe I make a mistake and, whatever. So like I want to add an exclamation point. So what I can do is I can combine the two conditions, right? So I can say, again, this is a different way of saying the same thing. So I'll say if pie and ice cream or not pie and not ice cream, that would be oops. exclamation point, and else I did not lie. So what is the logic here? So the two ways in which I can say oops is both a true or both a false, right? So the way this condition would be true is if the left-hand side is true or if the right-hand side is true. In this case, they cannot both be true at the same time, logically. Right? And that is exactly what OR does, is it says if one of them is true, then do the oops. Right? And the way this would be true is if pie is equal to true and also ice cream is equal to true. The way this would be true is if pie is false and also ice cream is false. And we are saying do one or do the other. Make sense? Yes. Right. Yeah. If I'm hearing you right, which I'm not completely because you're kind of far away. But basically, yes. So I think what you're asking is, well, like if the conditions on line 38 are not satisfied, then it must be that I did not lie, because the only other things that could happen is, you know, the other two of the four possibilities that are listed over here. Okay. Cool. Other questions? All right. So, like one reason I do this is it's kind of fun and funny. The other reason is to kind of like show that there's like multiple ways of getting there, in the same way that if you're solving a problem in calculus, sometimes there's multiple ways of getting to the right answer. Now, here, I would say there is kind of a very concise, elegant way. And there is also kind of this way, which I think is kind of the most readable. But again, different people might have different tastes there. All right. Yes. So the question was, what happens with the runtime? And the answer is, well, like none of those take too long. Like I would not worry about it, but you can think about it as how many operations do you take? And here, like, well, you would need to compute this. And technically, if this is true, you would not compute anything else. But this might not be true. And then you would compute this. And this is already 2 computations. And then you do the OR. So that's 3. So that is more than the first way, technically. Okay, so that was a bit of an advanced kind of preview of what's going to happen. So the answer is technically the first way would be a little bit shorter. Okay. However, so in Python, it would be shorter. In other languages, the compiler would probably optimize it away for you anyway. On modern computers as well, what's happening is, you know, if there are if statements, the processor is actually also trying to optimize, and it would sometimes try to compute in parallel every condition. And in practice, it might not actually take longer. In Python, it would though. So that again was kind of an answer to a more advanced question. All right. Other stuff? All right. So I wanted to do one more slide. Let's see if I can show the slide now. Aha. So I wanted to point out kind of a similarity between kind of normal algebra and Boolean algebra. Not like normal, whatever, like the one you know. So I'm not going to test you on this, but I think it's kind of like fun to point out that like the reason it's called Boolean algebra is that it kind of works the same as you know, algebra with integers. So if you think of true as being positive and of false as being 0, then AND kind of works like multiplication and OR kind of works like addition. So AND works like multiplication in the sense that false and anything is false in the same way that 0 times anything is 0. Or works like addition in the sense that positive plus anything is positive, and the only way to get a 0 is 0 plus 0 if you're talking about positive integers. So that by itself would not be that interesting, but if you logic it out, what you'll see is that something like the distributive law would actually work in Boolean algebra in the same way that distributive law works in algebra with integers. So, fun fact. All right. Yes.
We take off the bracket, for example, the A plus B times C. Then we will have the operation of the B.
So it works exactly the same as normal algebra, in the same way that, like in normal algebra, if you remove the parentheses, it's a different quantity. It would also not work out to be the same in logic as well. All right. So we're not going to be doing logical computation. The whole point is to outsource it to the computer. This is just kind of to point out why it's called algebra. Generally, if you have an if statement, you just kind of say what you want to say in the condition. All right. Okay, questions about this? Okay, so one last thing that I want to do is a multiple assignment in Python. So this is an extremely small thing. We'll do one application. So if you want to say something like A equals 1, B equals 2, C equals 3, you can also use the commas in order to do what's called multiple assignment. So assignment, remember, means take the right-hand side and put it in the left-hand side. So this is just putting 1 into A, 2 into B, 3 into C. Make sense? So one application of that is swapping the values of two variables. So if what you have is something like this, okay, so let's do something funny. So let's say that Alice is an ECE and Bob is an ANSI, and you want to make Alice have the value of Bob and vice versa. Okay. So what you can do is you can say Alice comma Bob is equal to Bob comma Alice, because this is saying put Bob into Alice and put Alice into Bob. Make sense? So okay. So the general thing, okay. So that was a little bit unfortunate. So the way you the usual convention in computer science is like names starting with A, names starting with B, names starting with C, and so on. So okay, so this makes it so that Alice has the value ANSI, and Bob has the value ECE. Make sense? So, all right. So how would you do it if you didn't have multiple assignments? So if you have, A equals to 42 and B equals to 43, then you cannot say A equals B, B equals A. And that would be because A equals B is making it so that A is now 43 as well. And then B equals A doesn't do anything because it takes A, puts it into B. And that just makes it so that A is still 43, B is still 43. Make sense? So what can you do? Well, what you can do is you can say, I'll put B into, I'll put A somewhere else. So I'll make temp B equals to A. So I'll again make A be 42 and B be 43. And now what's going to happen is A was put into temp. So now A is 42 and B is 43. And temp is now 42. And now I can replace A with B. So now A is 43 and B is still 43, but I have the old value of A in temp. And now that that's done, I can say, okay, so now I can put temp into B. So this makes it so that A is 43 and B is 42 and temp is also 42. Make sense? So one thing to think about, and if you know the answer, don't like shout it out, is if A and B are integers, but you cannot use multiple assignments, how to swap the values. So this is kind of a standard kind of puzzle. You can think about it. There is an answer, so you don't have to use temp. So without using temp. I'll give you kind of the first step. Work out what to do. It's not super easy, but it's doable. So if you want to just think about it. Right? Okay. Questions about any of this? All right. So I now just want to do a few more examples with locals and globals. I kind of think that that you need it. We're celebrating International Talk Like a Pirate Day today. It's a little bit early. So it's tomorrow actually, but there is no lecture tomorrow. So if you don't know about pirates, they kind of talk like this. So they say ahoy for hello and avast ye for stop. Yeah, you know. Okay. And on International Talk Like a Pirate Day, you talk like this. Okay. All right. That was the context. Again, if you don't know, so what pirates do is they plunder things. Okay, so let's say that I want to define. So plunder means steal someone's stuff. If you don't know, so let's say that I want to plunder some of your grades. It's an example. It's not real. So again, plunder means like to pirate, to steal. Okay. Okay. So let's say that grade is 85 and I want to plunder it by 3 points. How would they do it? So I want to say plunder grade and I want for grade to be 82 now. Not want, need, okay? So how would one do it? So think about it for 30 seconds. So I want for grade to be 82. All right, suggestions? Yes. Yes, spoken like a true pirate. So what you want to do is you want to say the job of this function is to reduce grade by 3. So this is a function with a side effect. The side effect is to change the value of grade to be smaller. So technically here, I wanted to say like, want it to be 82. That's not necessarily plundering. That might be the other way. But I'll just reduce it by 3. So I can say grade is equal to grade minus 3. And I need to say that grade is global. Yes. No, it wouldn't. So the question was, would it be an error? The answer is it would be an error if you also said that grade is a parameter. But here, there is no conflict between global and local because the only thing that exists is the global grade. Yes. Great. So let's do a different version of this with the return. So if you said return grade minus 3, then if you just, so first of all, if you say plunder grade incorrectly, so I'll just copy this. This would just be an error by itself because you need to supply the grade. You could try and fix it and say plunder grade incorrectly of grade. This would run, but it would not print anything. So this has the value 82, but doesn't have the instruction to print anything. Right? You could then fix it and say print all of that. So that would work. All right. So the way to think about it is, again, to think about the ways to communicate to and from functions, right? So here, what we're saying is we're communicating the information from the function, from the main block to the function. So that works. And then we're also communicating grade minus 3, but we're not using this information anywhere. So that is why it's not printing. The way to think about this is we're communicating the value from the main block to plunder grade by setting the value of the global variable grade that plunder grade then accesses. And then we're communicating the information from plunder grade by making the value of the global variable grade different. Yes.
Where to get rid of the argument grade and just put global grade on top of return with 0.
Again, with the hypothetical questions, which I unfortunately cannot exactly follow, but let me try. That's fine. But so let me try to reproduce it. So we cannot have a value that's grade that's both global and local and have it be changed. So we could do something halfway. We could communicate the information to the function by setting a global variable, but get the value from the function via return value. I think that might be what you're asking about. So let's call it plunder grade 2. So we can do something like this. And then what would happen? So we can say grade is equal to, okay, I think you deserve an 87. And then what we can say correctly is grade is equal to plunder grade 2. So what I did, by the way, is I got the options, I used the arrows, and then I pressed tab once I've selected the correct option. Okay. So that would work, right? So we're setting the global variable grade to 87. And then we're saying run this function. What this function does is it looks up the 87, subtracts the 3. The value of this would be 84. And then we're saying put 84 into grade. Make sense? All right. Yes. So if you are not changing the value of grade and are just looking it up, you do not have to say global grade, and usually I would not. So if you had said global grade here, that would also work, but that is optional. Make sense? All right, other questions? All right, let me just do one more example and tell you a joke about pirates, and then we'll be done. Again, this is kind of like the same kind of thing. So and just for the sake of the example, we already did an example like that, just to show that you can also communicate strings. So I can have a paratify string function, and I can say, like, ahoy. Something like this. Okay. And then I can say something like print paratify string. So something like this. So what would happen here is we're taking Praxis is awesome, setting it to S, and then the value of this entire thing would be ahoy, Praxis is awesome, comma matey. Let's run it. So I'll comment all of this out. So I'm highlighting everything and pressing control control T, sorry. All right. Let's do it like this. So control R and Piezo, actually. So this is all now commented out. So if I run this would be something like this. Okay. I could also do something like pirate print. And instead of returning, I can print. In which case, this is a function with a side effect. So pirate print, and I can just say, integral. And that would just print without having to say print. I see there's no time for a joke, so I'll tell it to you on Friday. Something to look forward to. So if I print this would be, again, the effect of printing ahoy, integral matey, and then the value of this is none. So this would also print none. All right. So that's like this. All right. So I will see you Friday. Thank you very much.